All right. All right. So in AOM, we have a lot of subgroups, and so far everybody has been focusing on the main use case of AOM, which is the video codec itself, which is fantastic. And as soon as the bitstream was frozen, there were other subgroups that start working more intensively. There was the hardware subgroup, of course, but there is another subgroup called the real-time subgroup that was focusing on an interesting use case that maybe you might not be aware of. So the first 10 minutes will be to tell you a little bit more about that use case that is actually happening within AOMedia. The second part of the presentation will be the application of AV1 in that use case in production, so people can get feedback about what kind of yet unresolved problem there is from the industry, each being a research opportunity. So if you look at the use case in AOM, everybody knows the video on demand, pre-recorded content, almost live, all live, 3 seconds. A lot of the companies that are member of AOM are a little bit schizophrenic here. They have products that are either video on demand, all live, YouTube live, Facebook live, Twitch, or even real-time completely, like Facebook Messenger, WhatsApp, WebEx, and so on and so forth. So some products belong to that. The common things about the video on demand is the latency is not really a problem. You have time to encode. Of course, you want to spend the minimum amount of time, but very often if you have to compromise the latency to get better quality, you're good. So Netflix has a lot of examples of different encoding optimization per title, per chunk, different codec, and so on and so forth, because every bit you're gonna win at that stage will be saving you a lot of money and increase the experience at delivery 1 million times for millions of viewers, right? So it makes sense. When you go into real time, so when you only have less than 1 second for the video to go from the source to any of the viewer, then you have to take into account a little bit more than the codec. You have to take into account the codec, the media transport, and usually a media transport. And for the people that have been working in real time for many years, it's not any kind of media server, it's an SFU, which means it's a relay. So there's a lot of things that are used otherwise, like transcoding server-side, ABR, and a lot of algorithms that cannot be used at the system level and that need to be replaced by other things. So here, the latency is king. You have people from the video conferencing world, Cisco WebEx, Polycom Video, that are part of that subgroup of AOMedia. We are more focusing on the streaming use case. Well, I'll get back to the difference a little bit later. And then you have other companies like Facebook Messenger, WhatsApp, who ought to be in that group, but as far as I know, are not represented. So here, the latency is king, and you cannot compromise on that. Traditionally, the encoder for real time is simpler. You do 1 frame at a time. You cannot have a multiple frame buffer because the acquisition time will already bring you over your latency budget. You cannot have B-frame for the same reason. So you do not achieve the same compression, but you need to be able to encode, encrypt, send, and retrieve a frame within a few, like 200, 300 milliseconds. That's really the key target there. Real-time requires end-to-end control, right? You cannot do encoding on one side, put it in a storage, wait for it, and take care of the delivery separately. You really, really need to have the entire chain to control the latency everywhere it could happen. So you need to have a real-time media transport. You need to have a relay logic. And the codec or defining the codec or the EBUs are usually not enough. So correspondingly, the deliverable for that subgroup is not only a specification for the encapsulation of the codec in a real-time transport, but also all the signaling mechanism, named SDP offer answer. All of those are separate specifications that belong to one of the standard committee, whether it's IETF or AOMedia for the RTP payload. But the SVC support. So the key to achieve, for example, ABR without transcoding on the server side is to be able to generate multiple resolution at the original encoder, and that is the SVC part of AV1 that not everybody speaks about. So it's not very important maybe in a video on demand case, but for the real time, it's key. If we do not have SVC, we cannot achieve real time and adaptability to the bandwidth. So that's a slide I wrote in 2015, so forget about the 2016 reference on the bottom. But in the web real-time communication or in a real-time protocol, there were two ways to achieve ABR. Either you were encoding different resolution in streams that were separately decodable, or you would go for SVC, where you have a base stream that is independently decodable, and then all the other streams are basically just incremental layers on top of it. The advantage of SVC here is that you have only one encoder. You use 30% or so less bandwidth because you do not duplicate in all the stream the low-level signal, right? And so on and so forth. Another one that is less known is like SVC allow also for much better network resiliency. So when you're going to stream your media over the internet and you don't have a buffer to compensate for the network problem, the SVC layers allow you actually to cope with up to 20% of packet loss without compromising the real time, while still playing at 30 FPS without buffer. So this is the use case, for example, for the web people. There are a few of you in the audience of WebRTC 1.0 that is supported in all the browser more or less today. You're supposed to be able to send multiple resolution to a media server in the middle that is then going to choose the resolution is going to relay to a specific viewer depending on the viewer capacity, be it bandwidth, display size, power, consumption, whatever. So So if you go into the real-time part of AOM, you still have two different use cases. You have the video conferencing. I think the best example is Cisco WebEx. It's represented here, and there is more good thing to say about that later. Video conferencing is different than streaming. Everybody is trying to speak at the same time, right? So everybody is supposed to be equal. But at the same time, it's only really working if only one person speaks, right? So you have a lot of optimization when it goes to scalability of video conference if you can detect who is speaking. So if you have 12 people in the room, you don't want to look at 12 people. You want to look at the people that speak. So if you're able to detect the active speaker, you put the active speaker in big on your screen, unless you don't like the guy and you mute him, right? And everybody else is on the small thumbnail because they don't really require your attention, they're not speaking. And then you automatically shift and you only display only the last 5 or last 6 people. So you can have 1 million people in the discussion. You're actually only going to send to people viewing the last 5, right? So it scales very well. Unfortunately, well, people looking at Game of Thrones, you can not only send Game of Thrones to the last 5 that connected to the conversation, or people that have a baby barking, or a dog barking on the back, or a baby crying. So you don't have that nice optimization. So for the streaming, you only one way, two ways. Source and viewer are very different logic and capacity. You don't have scaling optimization. So the scalability for streaming requires that you actually cascade different media server. While usually in video conferencing, you do not cascade for scalability issue, the size of the conference being sustainable for a single server. You might cascade a little bit for geographical distribution to have quality of service, but not for scalability. So here, there is a big challenge in terms of testing, right? Wrong again. So testing, if you're P2P one-to-one, everybody is happy. End-to-end encryption is easy. There is only one leg. There is no media server and everything. And scalability is not really a problem, you too. If you only want one server, here again, the two cases can be tested the same. But once you start doing million of viewers, which is the minimum for a lot of user of streaming technology, you start having a problem. Usually, people that do live, YouTube live, Facebook live, all those guys have a scheme a little bit like that. The person that is capturing, that is broadcasting the stream, encode the first time with as real-time as possible protocol that is left today called Flash, that is going to die very soon. Send it to an ingress node or an infrastructure that then is going to decode and then re-encode again in different chunks and different resolution, prepare the HLS file, the MPEG dash, and so on. And then it's stored somewhere online for distribution. And at delivery time, you can do all kind of optimization. That's less than ideal, of course, without speaking about the storage on disk. That takes a little bit of time. If you want to do an event and be end-to-end, the transcoding is costing a lot. So the simulcast, or even better, the SVC, since everyone has SVC directly in it, allows you to, in the case of a single server, already get twice less transcoding, right? So instead of having one encoding, decoding when you send to the ingress node, and then encoding and decoding again when you delivery, you only have one encoding at the source and one decoding at the source. So that allows to cut the latency almost in two just by doing that. So if you look at the event in the past year, in the history of everyone with a focus on real time, for me, I was happy to join AOMedia on January, but that's not a big event. I think the most interesting was Cisco, who demoed the first real-time AV1 integration in the full stack, RTP, WebRTC, everything integrated in WebEx. So not only the stack, but really the entire system. It was in June at the Big Apple New York event. What they mentioned at that time is that it was not SVC. They didn't support SVC, and they didn't think they were going to open source it. But it was a feast to see something running on a normal hardware, right? It was a MacBook Pro and a few computers like that, right, Thomas? But that was mind-blowing. So we had an implementation that we had done for Halloween the year before. It was nowhere close to real time. It was 2 frames per second. And then we see them coming here and do that and say, damn, we need to do something about it. Well, eventually we didn't. Because in the meantime, the Google guy had done a very, very good job with LibAOM. LibAOM had a new real-time mode. And so we didn't have anything to do but to upgrade the LibAOM implementation, recompile our software, and suddenly we had real-time WebRTC implementation. So there were a few differences. We didn't have SVC either. This is quite complicated. We were based on open source and happy to open source it for anybody that wants to play. And we were doing a streaming use case where they were doing WebEx, which is a video conferencing. But that's small detail. I think that means that today, everyone is almost production ready for real-time application, right? Even though to really go there, you need SVC. That's a little bit complicated and that will require more work, but the biggest part is done. So in the real-time subgroup of AOMedia, one of the deliverables is the payload. So part of the payload is easy. I take my AV1 OBU, how do I fragment them, or how do I pack them together to fit into another layer, right? In that case, the RTP. People that will do HLS, so you have to do the same thing with HTTP and on the layer above. It's a fragmentation, a packaging problem. It's not very difficult. What is difficult is how do I handle the layer information, and how do I add information in RTP to make the life of the media server easier. So Google was even better than that. They did some tests and showing that just using the normal 28 modes you have in the AV1 codec, you still had a disparity in CPU and bandwidth usage. And so since you need to, in real time, to make sure that you don't go over the bandwidth, a redistribution of the dependency prediction in the tree structure was allowing to get a better, smoother experience and use less bandwidth altogether. Then we realized that the operating point bit mask was not enough for the decoder, sometimes for the media server to decide which packet was used for which layer. So we needed to have some information, and that is more decoding centric. So we created something called the decoding target information that tells you for a given target, let's say I want quarter spatial resolution and half frame rate. Okay, what are the packet? What is the dependency chain that I must have in place to be able to decode that and to put the packet together, right? By putting this in the RTP header and not in a payload, that allows not only to have the media server do the work without reading the bit stream, but also to support end-to-end encryption where the payload would be encrypted and not accessible. Again, the good job from LibAOM. We do that almost every week. We did it again on June 27, which is the day Cisco made the presentation and got us excited. And we realized at that time that LibAOM that was on the bottom on a normal setting just went above the 30 FPS mark for 1080p and even 56 for 720 on a $50 Dell desktop, right? So super excited. That makes it everybody can try now. We put the source in libWebRTC, which is the WebRTC stack implementation that is used in every browser today, so that once it's done and done well, Chrome will get it first, then Mozilla will just update their fork, Safari, Edge is based on Chrome, and so on. So the tests are going to be exciting. If it's not tested, it's broken, but that's to come, so I'll show that next year at this event. So now, let Richard speak to you a little bit about the impact of adoption of AV1 in a full system, and what are the problems that it raises and that requires some research work and collaboration. And then we answer the question together after.